what's up guys? Before we get into this whole new series of solving physics papers, let's talk about the one most important thing in the world of physics, and that is formulas. Now, I'm here to show you a cheat sheet with all the formulas you could ever think about during your course of physics. And in order to receive this cheat sheet, I'll need you to comment down below your email address so that I can send you this. Plus, I need you to hit that subscribe button and the like button. Make sure you do that, or else I just won't send you the cheat sheet. Jokes, I'll send it to you anyways. Okay, now let's get back into the main purpose of this video, which is, let's just go back all the way to the top. Okay, yeah, chill, I'm getting a bit of a technical error. Yeah, so we're going to go into this physics and math tutor papers, and we're going to look at density question paper 1, which has approximately 7 questions. Let's just get started. Okay, so the first question is, figure 3.1 shows an old tank that has a rectangular base of dimensions 2.4 meters by 1.5 meters. Now, the tank is filled with oil of density 850 kilograms per meter cubed to a depth of 1.5 meters. Part A, Roman 1. Calculate the pressure exerted by the oil on the base of the tank. Now, when we talk about pressure, we need to know the formula for pressure. Now, we are given density, we're given depth, and we know G, as in gravitational strength or gravitational pull. So now that we have this set of information, we know that the formula to use is dGH, density times G times height. So we're going to just write down the formula and put in the variables in its correct place. So we're just going to take 850 times 10 times 1.5, and we get that the final pressure is 12,750 pascals. What does this mean? That means on that area, that base, there's a force of 12,750 pascals or Newton per meter squared acting on it. I hope you get the picture. If not, I suggest you go to YouTube and search videos for physics by Crash Course. Okay. Part 2. The force exerted by the oil on the base of the tank. So now we want to know the force. Now, in order to find force, we need to find a formula that links force, area, pressure, and basically the variables together. Now, if the formula that links force and pressure together is force over area. So we're now just going to put them in their correct places, the variables, and leave F as it is. So P is going to be pressure, P, 12,750 is equal to force over the area. Area is basically length times width. So now the base of the tank. So we can see over here, oh my god, these pop-ups, yeah. So we're just going to calculate the base area of the tank. So how will we do that? As you can see, you have 2.4 and 1.5 down there. We're going to multiply them together because area is length times width. So 2.5 times 1.5 is our area. So now that that is our area, we're going to multiply together. Multiplying them together gives us 3.6. So 12,750 is the force divided by 3.6. Cross multiply and we get the force is 45,900 newtons. Part B, the force calculated in Part A, Roman 2, is the weight of the oil. Calculate the mass of oil in the tank. So, what is weight? Weight is basically mass multiplied by the gravitational strength. So, basically mg. Now, what is the gravitational strength in this case? It is 10. Now, what is the weight? The weight is 45,900. That is given to us by the question. So, what is the mass? So 45,900 is equal to the mass multiplied by 10. So we're going to try and isolate the m. So we're going to divide both sides by 10. Dividing both sides by 10 gives us mass is equal to 4,590 kilograms. Part C. When he is checking the level of oil in the tank, a man drops a brass key into the oil and it sinks to the bottom of the oil. State what this shows about the density of brass. Remember, things float on each other because of density. So you could see ice floating on water because ice is less dense than water. And if something sinks below water, or in this case, if something sinks below the oil, that means that object has a greater density than oil, such that it can go deeper. That's what this experiment kind of shows about the density of brass. Part 2. Explain how attaching the key to a piece of wood could prevent the key from sinking. Now, let's read what I've written here. It won't sink as average density of wood plus key is less than the density of oil. So what I mean by this is, you see, the density of the wood is very low. such that wood can float on pretty much water, pretty much anything. Now, if I attach wood to the key, the wood would still float because its density is plus the key is still greater than the density of the oil. Hence, it would still stay on top, and that's why the key basically won't sink. Sink as in hit the bottom of the tank. Okay, so there's this properties bar getting up here. Sorry if this kind of thing, I'm just having a lot of laptop issues. Hope you enjoyed the video. Please smash that like button, okay? Counting on it. Part 2. Question 2. A student wishes to find the volume of a piece of wood of irregular shape. Her experiment requires the use of a small brass object of mass 200 grams. Calculate the volume of the brass object. The density of the brass is 8.4 gram per centimeter cube. Remember, density is mass over volume. We are trying to find volume, so we're just going to put everything in its correct place. So wherever you see D, we're going to put the value of density. Wherever you see M, we're going to put the value of mass. And wherever you see V, we're going to leave V blank. So the density is 8.4. 8.4 is equal to 200, which is the mass, over V. Cross multiply, so 8.4 times V is 8.4 V is equal to 200. We want to isolate V, and hence we divide both sides by 8.4, and we get that the volume is 23.8 centimeter cubed, and you can approximate that to 24 centimeter cubed. So now let's move on to part B. To find the volume of the piece of wood, the student has a measuring cylinder, a supply of water, and the brass object in A. The piece of wood and the brass object are small enough to be placed in a measuring cylinder. The piece of wood does not sink sink in the water. Slight typos when you convert the document, sorry for that. Suggest why. You see, if something does not sink, it means that its density is lower. It does not have that much, it's not that heavy. It's not as packed. Its molecules aren't as packed closer together to sink. Hence, wood does not sink, which means the density is less than water. Okay? Yeah. Part 2. Describe what the student does to find the volume of the piece of wood, stating the measurements that she makes and any calculations required. So before we find out the volume of this irregular piece of wood, we need to first get a graduated beaker, fill in liquid, basically water, to a certain amount. Actually, not water. We need to find a liquid which has less density than water. So let's say oil or something. So we're going to put that um, inside the graduated beaker, and then we're going to put the wood in it, and then if the wood sinks, it'll show a rise. We're going to take the final reading, subtract the initial reading, and we're going to get the volume of wood. Or what we could do is this: we could attach the brass to submerge it. But before attaching the brass to submerge it, we need to first place the brass in the water. We calculate the difference in volume, and that is the amount of volume that is not required. We're going to subtract that from the final amount, attach it to the piece of wood. We're going to get a new reading, and we're going to take the new reading, subtract the old reading, and again, we're going to come back to the same volume of wood. Okay, so let's scroll down. A student has 500 identical rectangular sheets of paper. The mass of 1 meter squared of the paper is 0.08 kilograms. Part A. Using a meter rule, she measures the length of one sheet of paper and its width. The length is 0.3 meters and the width is 0.21 meters. Calculate the mass of one sheet of paper. So we're going to first calculate the area, because you see 1 meter squared is 0.08 kg. So how many meters squared is this piece of paper worth? Basically equal to. So we're going to calculate the area, 0.3 times 0.21, and this paper is 0.063 meters squared. So 1 meter squared is 0.08 kg. How much is 0.063 meters squared? Cross multiply, and we get that this is 5.04 times 10 power negative 3 kilograms. The student makes a single pile of the 500 sheets of paper. With a meter rule, she measures the height of the pile. The height of the pile is 0.048 meters. Calculate the density of the paper. Now, what is the formula for density? Density's formula is mass over volume. What is mass? The mass of one paper is 5.04 times 10 power negative 3. Now, there are 500 sheets of paper. So take that, multiply it by 500. Over volume. volume is also length times width times height. Basically area times height. So we know the area is 0.6063 and we're going to multiply it by the height of the paper. So that multiplied by that gives us 3.024 times 10 power times 10 power negative 3. That's our volume. Divide 2.52 by that because basically 5.04 times 10 power negative 3 times 500 is 2.52. Divide that by 3.024 times 10 power negative 3 and we get that the density is 833.3 kilograms per meter cubed. The dot on 3 represents a recurring decimal. Means it's 33333, never ending. Part B. A second student has only 5 sheets of the same type of paper. Suggest how this student determines the density of the paper to a similar accuracy. Additional apparatus may be used. So he can use an electronic balance to measure the mass of the paper. Because remember, the formula is mass over volume. Now we need to calculate volume. We know length and width. Now the height can be found by using a micrometer screw gauge. So the way we use a micrometer screw gauge is we place it between the anvil and spindle and we screw the thimble. We rotate the thimble until they kind of touch and the paper is held firmly within. We take the reading on the datum line and we see the reading and we kind of note it down. Take that reading multiplied by the area and we get the volume, and we take the mass that we found on the electronic balance divided by the volume and we get that the density is somewhat the same. Okay. Question 4. A student has a large number of coins of different diameters, all made of the same metal. She wishes to find the density of the metal by a method involving placing coins in the water. State the formula needed to calculate the density. Mass over volume. Describe how the measurements of the required quantities are carried out. So basically, if you need more time reading this, I've written in bullet points, pause the video and go through this. Now let me explain. So what we're going to do is we're going to place water in the measuring or graduated cylinder. Graduated cylinder is basically the one with markings on it. Then we're going to record the initial volume. Then we're going to place these coins inside. We're going to record the new volume and we're going to subtract the new volume from the old volume. And then that's going to give us basically the volume of the coin. That's one part, and then using the electronic balance we're going to find the mass of the coin and then we're going to divide it by that, and that's going to be the density. State one precaution when carrying out the measurements in B to ensure that the result is as accurate as possible. Remember, when you're using the graduated beaker, make sure your eye is level and you read below the meniscus. What I mean by meniscus is this curved sort of line there. Reading from above could give you an incorrect reading, so just be sure to take it eye level and below the meniscus. Okay, so question 5. A student wishes to determine the density of a small irregularly shaped stone with the aid of a label diagram. Describe an experiment to determine the volume of the stone. I don't think so I need to explain this to you guys. It's quite obvious. You have the beaker, fill the water, record the volume, dunk the stone, record the new volume, subtract the 2 volumes. Read the diagram, everything's explained in here. Pause the video and go through it. Okay, state the other quantity apart from the volume that must be measured in order to determine the density. Remember, what is density's formula? Mass over volume. Now say, apart from volume, what else is left if volume is removed? Mass. That's it. Okay, this is going to be a repeating question. Say the formula that you use to calculate the density, mass over volume. Okay, so part C. The student now wishes to determine the volume of a small irregularly shaped piece of wood that floats in water. He notices that a small lead weight tied to the wood makes it sink in water. Describe how the student can adapt the experiment in A to determine the volume of wood. You may draw a diagram. So you're just going to attach the wood to a weight such as a stone, subtract the volume of the wood and stone from the volume of the stone. That's it. So I mean by this, attach it to the stone, let the water sink. Okay, so you're going, you know the volume of the stone. Okay, so the wood and stone now. That's the combined volume. We're going to take the wood and stone. We're going to find the volume of those two. Now, that new volume we're going to subtract it from the stone. And then what's going to happen is we're going to be left with wood. It's quite simple. Oh, okay, I'm going way too far. Anything here? Okay. Let's move to the 6th question. Define density. Density, whenever you're asked to define something in physics, you can easily just refer to its formula to define it. So if I was going to say define pressure, you're just going to be like force divided by area. And density, you can say it's mass divided by volume or mass per unit volume. It's quite simple. The density of aluminium is 2.7 grams per cubic centimeter. The thickness of a rectangular sheet of aluminium foil varies but is much less than 1 millimeter. A student wishes to find the average thickness. She obtains the following measurements: mass of sheet 60.7 grams, length of sheet 50 centimeters, width of sheet 30 centimeters. Calculate the student's values for Roman 1, the volume of the sheet. Now remember, density is mass over volume, volume is mass over density, basically if you cross multiply the formulas. So we're just going to take the mass, they just want the volume, so we're just going to take the mass, 60.7 grams, over the density, 2.7, all the way here, and we're just going to divide them two together, and we get that the volume is 22.48 centimeter cubed, or 22.5. Now, the average thickness of the sheet. Now remember, we have volume. The formula for volume is length times width times height. Thickness, basically the height. We know the length and width, and we know the volume. So 22.48 is equal to 50 times 30 times an unknown value. So 22.48 is equal to 1500 H. Divide both sides by 1500 and we get that the thickness is 0.015 centimeters. Quite small. Another student, provided with a means of cutting the sheet, decides to find its average thickness using a single measuring instrument. Assume the surfaces of the sheet are perfectly smooth. So you could use a micrometer or a vernier calipers or digital calipers. Whatever you want to write, it's a 1 mark question. Describe the procedure she should follow to obtain an accurate value of the average thickness of this sheet. Details of how to read the instrument are not required. So basically, it's a 3 mark question, so you want to write 3 points. So you want to make sure that the device is calibrated to 0 before you're actually recording the data. Then maybe you might want to cut the sheet into more pieces and take the reading in case you're coming up with the 0 error. And you might also want to just fold the sheet instead of cutting it. All depends on which big brain solution you want to go with. Okay, so yeah, moving on. Okay. Figure 1.1 shows a side view of a large tank in a marine visitor attraction. The tank is 51 meters long and 20 meters wide. The seawater in the tank is 11 meters deep and has a density of 1030 kilograms per meter cube. Calculate the mass of the water in the tank. So we're trying to find the mass. Density is again mass over volume. Volume is LWH, length times width times height, so you can see I've written it out. So 1030 is equal to mass over 51 times 20 times 11. So 1030 is equal to mass over 11,220. Cross multiply. Put this in your calculator, you'll get a really long answer. I've just approximated. The mass is 1.2 times 10 power 7 kilograms. You do not want to break this aquarium. You're going to have a lot of water coming at you. The pressure at point M, halfway down the large green panel, is 60 kilopascals more than the atmospheric pressure. Calculate the depth of M below the surface of water. So basically this depth is basically change in height. So we're just going to use the same formula, dGH. Pressure is density times gravitational potential energy, basically G, whatever you call that, I forgot it, multiplied by change in height. So the pressure is 60 kilopascals, 60,000, because because you're using change in height. 60,000 is equal to density 1030 times 10 times change in height. Now 1030 times 10 is 10,300. We're going to try and isolate this change in height, so we're going to divide both sides by 10,300. And 60,000 divided by 10,300 is 5.825 meters. That's the change in height. That's the depth. That's the depth, basically. The viewing panel is 32.8 meters wide and 8.3 meters high. Calculate the outward force of the water on the panel. Assume that the pressure at M is the average pressure on the whole panel. So pressure is force over area. Force is pressure times area, and area is length times width, and pressure is dGH. So basically we're just going to need to take pressure multiplied by area. So dGH multiplied by length multiplied by width. So the pressure is basically 60,000, 1030 times 10 times 5.825 times the dimensions given to us here, 32.8 times 8.3 So that multiplied together is 272.2. 60,000 times 272.2 is 1.6333 times 10 power 7, and that's the average force. And that's the end of the video, guys. If you enjoyed this, smash that like button, hit that subscribe button, and turn on the bell for all notifications to get a notification every time I upload a video. See you guys next time.